So welcome to stage 11, finding critical points. Now the basic idea of a critical point is it's just a value for x where f prime equals 0 or where f prime doesn't exist. Now Fermat's theorem basically says that if you have a local min or max, then that value of x is a critical point, which makes sense because if you have a maximum or a minimum, you have a horizontal tangent line. And a horizontal tangent line has a slope, which is the derivative, which is equal to 0. So it's basically saying that f prime equals 0, which is the definition of a critical point. Okay, so now to find a critical point, you're going to first find the derivative to set it equal to 0. Now I get my derivative, and this is just a polynomial, so it's defined everywhere. There's no place where f prime doesn't exist. So I'm just going to set it equal to 0. Okay, I'm going to take out the 3 first to make it a bit easier for myself. And so now this is going to factor to x minus 4, x minus 2. Okay, so I set each part equal to 0. Remember, the 3 on the outside, that's never going to be equal to 0, so you're not getting a critical point from there. So now my critical points are going to be at 4 and 2, so I can write CP for short for critical point. My critical points are at x equals 2 and x equals 4. Done. Okay, so another example. So here I'm going to find my derivative. Again, my derivative is going to be a polynomial, so I'm not going to have any locations where f prime doesn't exist. So I'm just going to look where it's equal to 0. So I factor out the greatest common factor. Then I'm going to set each part equal to 0. Okay, and solve. So I get 2/3 and 0. So my critical points occur at x equals 2/3 and 0. So what about the absolute value function? So let's say that we just have, the absolute value of x. Now if you think about the graph of that function, the absolute value of x is just a V shape. But when we were first doing derivatives, we said that the derivative is not defined at cusps or corners or anything like that. So at x equals 0, you have this corner, and that's where f prime doesn't exist. So the derivative doesn't exist at x equals 0, therefore a critical point exists at x equals 0. So let's look at a different absolute value function. Let's say the absolute value of 2x plus 3. Now the corner is always going to occur where the inside is equal to 0. So I'm going to set the 2x plus 3 equal to 0 to solve. I get x equals negative 3/2. This is the x value where the corner occurs. That is where the critical point is because f prime doesn't exist. So now let's look at a function that's a quotient. So we're going to have to use our quotient rule to find the derivative of this function. And I'm just going to write it out with the f and g. If you're comfortable not writing it all out, that's fine. Okay, so I'm going to use my g f prime minus g prime f all over g squared. And I'm just going to simplify this as well. I'm not going to multiply out the bottom. That will not help me at all. I'm not going to multiply out the bottom, but I am going to simplify the top. Okay, now what you have to think about for a quotient is where the top is equal to 0 of the quotient is where the whole g prime is going to be equal to 0. And where g prime equals 0, you get critical points. Now you also have to think, where is g prime not going to exist? It's not going to exist when the bottom is equal to 0. So we have to look for both the top and the bottom of our quotient where that's equal to 0 to find all our critical points. Okay, so g prime equals 0 when the top, the negative x squared plus 1 is equal to 0. I'm going to factor out a negative 1 because then it's a little bit easier to see. It's a difference of squares. So x minus 1, x plus 1. So then I'm going to get my two values of plus or minus 1. Okay, now negative 1 is never going to be equal to 0. But I do have x minus 1 equal to 0 or x plus 1 equal to 0. So I get x equals 1 or x equals negative 1. Okay, so those are two critical points, but now I have to look where g prime doesn't exist. And that's going to occur when the top of my, where the bottom of my function is equal to 0. So where the x squared plus 1 squared equals 0. Now really it's just the x squared plus 1 where that is equal to 0. Because you square 0, you'll get 0. So I subtract the 1, I get x squared equals negative 1. Now I can't take the square root, well, I can take the square root of a negative number, but I'm not going to get any real solutions. And I'm only interested in real. So I'm not going to get any real solutions here. So then my only critical points are occurring at x equals positive or negative 1. And I hope this video is helpful.